light, shadows, and reflections. We see objects all day. From the time we open our eyes in the morning to the time we sleep at night, we see the things around us. We observe their colors, shapes, and sizes. In the daytime, the light of the sun is sufficient for us to see the objects around us clearly. But in the evening, when the sun sets, it becomes dark and we can't see things easily. What do we do then? We light a candle, a switch on a bulb, or a tube light. When the light from these sources falls on an object and then travels to our eye, we see the object. So, the light enables us to see objects. We can therefore say that light is an invisible form of energy which gives us the sensation of sight. Light is essential for the existence of life as green plants prepare their food by the process of photosynthesis by using the energy of light. Sources of light. Any object which emits light is called a source of light. The sources of light can be grouped under two categories: natural and man-made or artificial source. Natural sources. Those sources of light which occur in nature are called natural sources of light. For example, the sun, stars, firefly, etc. Man-made or artificial sources. Those sources which have been made by man are called man-made sources of light. For example, candles, oil lamps, earthen lamps, lanterns, gas lamps, electric bulbs, fluorescent tubes, torches, tube lights, etc. are all man-made sources of light. These enable us to see the things even when the sun is not there. Luminous and non-luminous objects. Those objects which give out their own light are called luminous objects. The luminous objects are also sources of light. For example, sun, stars, candle, bulb. Those objects which do not give out light on their own are called non-luminous objects. These become visible only when light falls on them. For example, moon does not have its own light. It shines when sunlight is reflected from its surface. Hot and cold sources. The sun is the brightest and hottest source of light for us. Fire always gives out heat. A glowing bulb is hot. What if we go near the stars? Will we feel the heat? Yes, stars are also hot, but because they are very far from us, we don't feel their heat. However, some sources of light are cold as well. For example, a firefly, a tube light, a CFL, etc. are cold sources of light. Transparent, translucent, and opaque objects. When light falls on a given object, the resulting effect is different for different objects. Transparent objects. Those materials which allow the light to pass through them are called transparent materials. Glass, air, cellophane sheet, window panes, glass tumbler, test tubes, and pure water are transparent objects. We can see clearly through these objects. Translucent objects. Those objects which allow only some amount of light to pass through them are called translucent objects. Butter paper, oiled paper, smoked glass, tissue paper, etc. are translucent objects. We cannot see clearly through these objects. Opaque objects. Those materials which do not allow the light to pass through them are called opaque objects. We cannot see anything through an opaque object. For example, book, ball, cardboard sheet, wood, etc. are all opaque materials.
Activity 1.
Take a clean glass, fill it with water, look at a lighted torch through the glass. Can you see the torch clearly? Glass and water both are transparent. Now, throw the water away and fill up the glass with milk.
Can you still see the torch?
Milk is translucent. Next, fill the glass with tea. You can't see the torch through the glass. A glass filled with tea is opaque. Light travels in a straight line. Switch on a torch in a dark room. Can you see a circle of light in front of you? Move the torch to your right. You will now be able to see objects on your right but not in front of you. Why do you always see only the objects directly in front of the torch? This is because light travels in a straight line. Have you ever seen the light from the cinema projector traveling to the screen in front of it? Are there any other ways to find out whether light travels in a straight line?
Activity 2. Take 3 cardboards of equal size.
Make a very small hole through the center of each. Make them stand on a table with the help of some support like modeling clay. Place the cardboards in such a way that their holes are in a straight line. Light a candle at one side of the table in such a way that the flame is in line with the holes. Look at the flame from the other end through the holes. Are you able to see the flame? Why? Now, move the middle cardboard slightly so that the holes are not in a straight line. Can you still see the flame of the candle? No. Thus we conclude that light travels in a straight line. The property of light traveling in a straight line is called rectilinear propagation of light. Rays and beams. You have learnt that light travels in a straight line, called a ray of light. A ray can be shown by a straight line with an arrow head showing the direction in which light is traveling. A collection of rays is called a beam of light. Shadow. You must have seen your shadow follow you everywhere. You might have also seen shadows of plants, animals, and other objects. We have studied that opaque objects do not allow light to pass through them. The dark patch formed in the space behind the opaque object, where the light is partially or wholly cut off, is called a shadow. Conditions necessary for the formation of a shadow are: there must be a source of light, there must be an opaque object which can obstruct the path of light, there must be an opaque screen on which a shadow can be formed, as it cannot be formed in the air.
Activity 3.
Aim: to study the formation of shadow. Materials required: a torch, black paper or tape, a ball, and a bare wall. Procedure: 1.
Cover the front glass of a torch with black paper or tape and make a small hole in the center.
This will give you a point source of light. 2. In a dark room, switch on the torch and point it towards the wall. 3. Place the ball in the path of light. 4. Move the ball towards and away from the torch.
Observations. When the ball was placed in front of the torch, its dash was obtained on the opposite wall.
When the ball was moved towards the torch, the shadow formed was dash in size. When the ball was moved towards the wall, the shadow formed was dash in size. Conclusion. You might have observed that when the object moves closer to the source of light, the size of its shadow increases, and when it moves away from the source of light, the size of its shadow decreases. In the preceding activity, if you change the color of the ball, does it have any effect on the shadow? Observe the shadows of various colored objects around you. Are they of different colors? You might have observed that your shadow is always black. Moreover, it changes its length and direction during the day. This is because the position of the sun changes with time during the day. The formation of shadow is a direct result of the rectilinear propagation of light. An opaque object casts a dark shadow. Translucent objects form a weak shadow, and transparent objects do not cast any shadow at all. A point source of light produces a shadow of total darkness. If the source of light is bigger, the shadow is not well defined. It then consists of two regions. 1. Umbra, region of total darkness where no ray of light enters. 2. Penumbra, a region of partial darkness surrounding the umbra. Some light reaches this region. Do the shadows give us an idea of the size and shape of the object? Let us find ourselves.
Activity 4.
Take a cardboard, a scale, and a pencil. Cut out a circle from the cardboard. Make a hole at the center of this circle.
In a dark room, switch on a torch. Keep it on a table in front of a wall. Hold the circular cardboard between the torch and the wall in such a way that you get a round shadow. Slowly rotate the cardboard till you get only a thin strip as its shadow.
Also observe the light passing through the hole. Repeat the exercise with the scale. Can you increase or decrease the size of its shadow? Now keep a pencil lengthwise in the direction of the light. The shadow appears as a small circular shape. Move the pencil so as to get an elongated shadow. The nature and shape of a shadow depends on the shape of the object, the size of the source of light and that of the object, the position of the source of light and the distance between the source of light and the object. Eclipses. Eclipse formation is also based on the principle of rectilinear propagation of light. Sometimes when sunlight falls on the earth or the moon, they cast shadows on each other. The eclipses occur because of these shadows. Solar eclipse. We know that the earth revolves around the sun and the moon revolves around the earth. When the sun, the earth and the moon come in a straight line, in which the moon comes in between the earth and the sun, the moon blocks the sunlight to reach the earth and the shadow of the moon falls on the earth. This phenomena is called solar eclipse. A solar eclipse occurs on a new moon day. Lunar eclipse. When the earth comes in between the sun and the moon, they are in a straight line. The earth casts shadow on the moon. This event is called lunar eclipse. A lunar eclipse occurs on a full moon day. Plane mirror and reflection of light. The bouncing back of light after striking a surface is called reflection of light. When the light falls on an object, it can pass through the object, transmission of light, get absorbed by the object, absorption of light, get bounced back or reflected back by the object, reflection of light. The objects having polished and shining surfaces reflect most of the light falling on them. A plane mirror is a thin, flat, and smooth sheet of glass having a shiny coating on one side. This coating is of silver metal and is protected by a layer of red paint. The silver coating makes the mirror shiny on the other side. The shiny surface gives maximum reflection of light. A mirror changes the direction of light. A plane mirror forms erect images. Regular and irregular reflections. The surface of a mirror is very smooth. Therefore, if a beam of light falls on it, the entire beam is reflected in only one direction. This is called regular reflection. However, the surfaces of most of the objects around us are not so smooth. When the ray or beam of light falls on an object with an uneven surface, it gets reflected to different directions. This is called irregular reflection of light.